Let's see if we can't come up with this situation where we're given a function and we want to find the derivative of its inverse. And we may not even know what the inverse function looks like. But let's start off with the idea that we have two functions, f of x and g of x, and they are inverses of each other. If that's the case, if that statement is true, then we understand through that verification process it means that f of g of x is equal to x. Well, now let's start applying some calculus here because I want to be able to come up with a situation. Let's say we're given what f of x is equal to, and we want to find the derivative of its inverse, which would be in this case g prime of x. So let's see what happens if we differentiate both sides of this equation right here with respect to x. So I want to take the derivative with respect to x of f of g of x, and I want to take the derivative with respect to x of x. Well, over here on the left side, that's pretty much a straight recitation of the chain rule. The derivative of the composition of functions f of g of x is going to be f prime taken at g of x times g prime of x. That's our chain rule. And over on the right side, the derivative of x is equal to 1. Well, if you think back to what I said we were looking for, if we were given the function f and we wanted to know the derivative of its inverse, in other words, if we wanted to know what g prime is, we now have that sitting for us, and we can actually come up with a situation where we write g prime of x equals, and we just need to divide this over to the other side, so it's 1 over f prime of g of x. And so now I have a formula here to find the derivative of a function's inverse. The derivative of its inverse is 1 over the derivative of the initial function taken at its inverse function. Now then, we're going to add a little bit more notation to this because I want to really just kind of address this in terms of a function f. So since g of x is the inverse, I'm going to apply some different notation to it here. Since g of x is the inverse of f of x, we can write, I'm going to replace g of x with inverse function notation for f, which is this little f with a notation of -1. Not an exponent, just saying that we're taking the inverse of f right there. So I can rewrite this. I can say the derivative of the inverse of f of x. And this is going to be kind of a true statement for us here. The derivative of a function's inverse is. So I'm looking at its inverse, and I'm taking the derivative, and that's what this notation is saying. The derivative of the inverse function is equal to 1 over f prime evaluated at the inverse function. And again, that's coming just from replacing these g of x's with our inverse of f notation. So we now have a formula where we can find the derivative of the inverse of any function, and we'll apply that here in the next video.